Hello class, good morning class. I hope everyone is doing well in your various homes. It is good to meet you guys again. We started a topic, algebraic expression, but unfortunately we couldn't finish before the second break. So now we want to proceed on, but before then I want to touch on the few things so that we can recap and later on move on. So right now we have an algebraic expression. One may ask, what is it? What is it about? What is the purpose? What is the essence of it? Is it actually important? You see, mathematicians in the past devised ways for us to represent numbers, for us to represent quantities, money, and the likes. But as we have the Hindu Arabic system, from 0 to 1 digits, and combining them to form huge numbers. We have the Roman numerals, I, IB, VIX, and the likes. But then came a question on how to represent unknown numbers in case you want to put them in an equation. You know, equation which involves an equal sign, where the left and the right must be the same. So in the case we have the right, for instance, 5 plus x is equal to 14. 5 plus a number is equal to 14. How do we represent that unknown number? Then we have to use a variable, a letter, to represent that. So my mathematicians came up with this very topic. Algebraic expression is actually a collection of letters, symbols, and numbers combined with at least one of the operational signs, which include the plus, minus, times, or division. So we want to just take some few examples of algebraic expression, how we can express the various numbers, equations using algebra. Now we have one there, 2x plus y minus 3. That means the x is unknown. You can say 2 times a number plus another number minus x. Here too, we can say 3 multiplied by a square of a, and also a square of, and also b and a c. Or you can put it in this way: the product of the square of a number and another number and another number. These numbers are all unknown. So how do we present them using the numbers that we are so used to, the Roman numerals and the Hindu Arabic system? So now we want to know how we can represent or how we can form algebraic expressions for a given mathematical statement. In case I give you a mathematical statement and I ask you to represent it in a form of algebra, how do you do it? Like I said earlier on, algebraic expressions always involve the letters, the symbols, and operational signs, and numbers as well. So now we have, let's use x. Let's use x to represent an unknown number, any number you can ever think of. The number is unknown, you can also say a certain number. So right now, in case I ask you, or someone asks you, 5 more than a certain number, how do you represent such a statement using algebra? First, we have already agreed on using x as to represent that certain number. It's unknown. So we have to just, so right now if I ask you to represent 5 more than the number, how do you present it? And before they agreed to use x to represent that certain number we don't know of, because I didn't give you any clue on what that number is. So 5 more than the number will be 5 plus x. It's like if I ask you, what number is? Okay, so I can ask you, 5 more than a particular number will give us x, will give us 7, sorry. 5 more than a particular number will give us 7. That particular number, how do you represent it? You need to use a variable or a letter to represent it. So right now, if I ask you 5 more than a number will give us 7. Right now, this number is unknown. So how do you represent this using algebra and then solving it? You need to just write 5 more than. Anytime you hear the word more than, it means you're talking about addition. And you hear less than, it means you're talking about subtraction. So 5 more than a number will give us 7. That simply means that 5 plus a number which we don't know of, and we've agreed to use x. 5 plus x is equal to that 7. So you can easily represent it in this form, and using the principle of linear equation, we can just take this 5 to the right side And we know any number when it's positive here and you take it to the other side, it becomes negative. So if we are to solve it, we can say 5 plus x is equal to 7. Then because we want to find what the x, we want to find the value of x, we let x stand at the left side, or we keep the x at the left side and we carry the 5 to the right side. So the 7 is already there waiting for the 5, and the 5 is positive here. So if it crosses the equal sign, it turns to negative. This is how it's going to be. You can say therefore x is equal to 2. So initially we didn't know what the number is, but this x helped us to represent it and later solved it. You can say the number is 2. So now you can come to me, or you can write and you can confidently say 5 more than 2 is equal to 7. I've already uploaded enough examples for you in my lesson notes, so as soon as you get there, you can have enough examples to play around with. We have 2 less than the number. How do you present such a statement? The number is unknown, it's certain. Yes, it's unknown, so we need to use a variable. Any variable is applicable. Any variable is usable. Because x is so we are so used to x. You are used to use x. So x minus 2 will give us. So I can ask you, for instance, I can ask you 2 less than a number is equal to 5. So how do you present this mathematical statement and then solve it? So I will just have to write a number. Like I said earlier on, anytime you hear less than, it means subtraction. When it comes to algebraic expression, when you hear more than, it means addition. So 2 less than, that means a number minus 2 is equal to 5. So if you are able to represent it mathematically, that means you can solve it. How? You want to still engage the principle of linear equations. Now we have x, we want to find the value of x. So that means we have to do away with whatever anything that has nothing to do with x. Now the right side and the left side, on the left side we have x minus 2, and we want to keep the x, or make x the subject. Meaning you have to write the x, then we have to take away the 2. The 2 is negative. When you put the equal sign, it changes its sign. Then the 5 is already there waiting for the 2. So as soon as the 2 crosses the sign, it becomes positive. Right now we have 2 here, we have to carry the 2 to the other side so that x can be kept here and we can make x subject and find its value. When 2 is negative here and crosses the sign, it becomes positive. And the 5 is already there waiting, so that will be 5 plus 2. Now we can confidently say x is equal to 7. Meaning 2 less than 7 is equal to 5. Good. And now we have 7 times a number. I can say 7 times a number is equal to 35. Now I don't know the number what it is, but I can use algebraic expression to express this mathematical statement and then solve it. 7 times a number, that means 7 times, the number is unknown, which we have agreed to use the variable x. 7 times x is equal to 35. And we know already that when we multiply a number or a constant by a variable, the 2 hug each other, they attach themselves. So right now we have 7x, we have 35 here. We want to make x the subject, that is, we want to find the value of x. So we have to do away with whatever is holding on to the x. Meaning we have to divide both sides by 7 so that we can get rid of the 7 attached to the x. Do that here, and this 7 will do away with this 7. And when it's 35 over 7, it simply means 35 divided by 7. And we all know 7 will go here, will cancel it, will divide itself 1, and 7 will divide 35 5 times. Therefore, we can boldly say x is equal to 5. 5 over 1, which is 5. As any number divided by 1 is still the same. So, at first we didn't know what the number is, or whatever number that you multiply by 7, that would be 35. But now we know that it is 5 that you multiply by 7 to give us 35. So this is how mathematicians devise, this is what some mathematicians devise to make things easy for us. I hope to see you in our next lesson.